Hello and welcome to the fifth of the Quest tutorial videos. In this video I'll be showing how you can work with multiple sites in Quest. So in Quest all the additional sites are separated into different little tab widgets, so you have the possibility of adding up to 6 sites, which is more than enough for wide-line NMR spectroscopy. And so when you fill in these extra sites, you must always fill them in the appropriate order. So if, for example, you add a third site before actually adding the second site, it will just ignore this third site and only simulate the first one. The extra sites, you also have the possibility of changing the lawnmower frequency and spin for these sites independently of that for the main site. This is useful if you're simulating NMR spectra, for example, for bromine, chlorine, rhenium, titanium, which have different isotopes with different lawnmower frequencies and spin, for example. But they can overlap in the same spectral window. And so you have the freedom to change the lawnmower frequency and spin for the additional sites. And again, you have the chemical shift tensor parameters, EFG tensor parameters, and Euler angles that you can add for these additional sites. And you can also edit the relative intensity of these extra sites. So if you want to add this site in, you can put a relative intensity of 100, and I'll just change the asymmetry parameter for this site. So now you can see the overlap between two different sites in this calculated NMR spectrum. So I'll just set the relative intensity to 0 just to cancel this one out. Additionally, if you don't want to have to copy all your parameters from one site to the next, you can go in Tools and then Copy Parameters, and for example you can copy the parameters to the second site, and so it takes the parameters from the first site and copies them over to the second site, so you don't have to change the lawnmower frequency and spin for every one of them. And so now this is, for example, a 2-site simulation. You can also copy the parameters to the third site, where now I'll add an asymmetry parameter of 1 for this third site. And so now we have this 3-site simulation for 3 spin 3 half NMR spectra in this case. I'm going to show an example with a experimental NMR spectrum. So I'm going to open the bromine 81, bromine 79 NMR spectrum of calcium bromide that was acquired at 4.7 Tesla. So this is because it's at a very low magnetic field and they have very large quadrupolar coupling constants, there's significant overlap between the two central transitions. And so in this case, I'm just going to read in the Quest parameter file for these sites. And so in the first site here, I have the NMR parameters for the bromine 81, and in the second site, I have the NMR parameters for the bromine 79. So they're both spin 3 half, but you can see that they have different lawnmower frequencies and relative intensities. So the 79 is actually has a higher natural abundance than the bromine 81, and the lawnmower frequency is a bit lower. So this one's at 50.1275 megahertz, whereas the lawnmower frequency of the bromine 81 is at 54 megahertz. So I can simulate the spectrum here to show the agreement between the experimental and calculated NMR spectrum. You can see that, just to make it clear, I'm just going to put this in frequency. So you can see that actually the left edge of the spectrum has almost twice the lawnmower frequency of the right edge of the spectrum. So it makes sense that the intensity actually decays from one edge of the spectrum to another. So I can, for example, scale the experimental spectrum up a bit by, say, 1.3 to show, for example, the agreement with these extra singularities. Now I'm going to demonstrate another functionality which is useful in Quest, and that is to simulate NMR spectra for certain isotopes which have 2 NMR active isotopes. So for example, you have the option to simulate chlorine 35, chlorine 37 NMR spectra simultaneously, titanium, copper, bromine, indium, and rhenium. I may add some extra possibilities if there's a need for it later. So for example, if I select titanium, and I can do tie site 2 to site 1, so this will make the first site titanium 47 and the second site will be calculated automatically as titanium 49. And so this is the spectrum that we obtain, where you have you only need to enter the titanium 47 NMR parameters in this site, and those for titanium 49 are calculated automatically. If you prefer to type in the NMR parameters for titanium 49 instead of 47, you can go in Tools, and then you can simply select Invert Order. And now in this case, the NMR parameters that you type in are for titanium 49, and the titanium 47 is calculated automatically. So I'm just going to go back to the example here where I had bromine 71 and bromine 79, sorry, and bromine 81 NMR spectra. And I'm going to show the utility of this tie to previous site option. So I'll just read in the parameters for only the bromine 81. And so when I simulate it, you see that only the singularities that originate from bromine 81 are simulated. And if I go to Tools, Common Spin Pairs, and then bromine 79, bromine 81, tie the second site to the first one, then what it does is it does this. So the problem here is it actually thinks that the first site is bromine 79 when in fact it's bromine 81. So you need to go into Common Spin Pairs and Invert Order to tell it that the first site is actually bromine 81, and then it properly calculates the bromine 79 NMR parameters. So I hope that this clearly demonstrates how to work with multiple sites in Quest. To go quicker, you can copy your parameters to extra sites, or you can do the same thing, kind of copy the parameters to extra sites, but for different spin-active isotopes. So I hope that this was useful, and I will talk to you in the next tutorial video.